Alrighty. And when last we left, we had a solution that contained either calcium or it contained lead or it contained both. Yes. And so what we had done yesterday is we picked something that would precipitate either the calcium or the lead, but not both of them. That way we could say, I got to precipitate. Yes, I had this one particular ion present. And in this case, we chose something that would precipitate the lead because lead is generally a less soluble substance than calcium. So we could have chosen any of sulfur, sulfide, chloride, bromide, iodide. We chose the bromide ion. And if you remember, we cannot go into the back room and get a jar of bromide ions. They have to come with a partner, and that partner has to be a cation. And who do we use as our partner cation? Sodium. Okay, so always when you need a partner cation, always use sodium. So we had added sodium bromide, and how much did we add? We added an excess. That's going to make sure all the lead is gone. Okay, and then we make a statement. If a precipitate forms, lead 2 plus was present. If no precipitate forms, no lead 2 plus was present. And then if a precipitate forms, right after this, we can write what we do to get rid of that precipitate, because what we've got right now is we have our first precipitate, the lead bromide, and that makes it cloudy. Okay, how will we tell if we get a second precipitate? We need to remove the first precipitate to see if we get a second precipitate. And last day we started looking at a method or two of getting rid of that solid. What was one of the methods that we used to get rid of the solid? We centrifuged it. That's the spinny thing. Okay, so here we have our spinny thing. We centrifuged it. All right, but then we need to pour the liquid off the top. Okay, so we need to pour the liquid and separate the liquid so we've got it in a different container. Just before we carry on with that, the solid, after we've spun it, is called the pellet. Yeah, perfect. And the liquid is called the supernatant. Super, that prefix usually means above or more than. And in this case, it means above. It is the liquid that is above the pellet. Okay, so the liquid that's above the solid. Now, the process of pouring the liquid off is called decanting. Okay, so this process right here, this is called decanting, where we pour the liquid off and leave the solid behind. Okay. Now, what ions would be present in this solution here? What we would have is we would have a precipitate, and I think it was, this is our precipitate, and that was lead bromide. Well, if we go back and we say, what did we originally have in our solution? We have we had calcium nitrate or lead nitrate. So we, in addition to possibly having some calcium, we will also have nitrate left over. Yes? So let's go. You're not going to have to do this. You're not going to have to say what's in here, but just for your own understanding, in here, there's going to be nitrate. There may be calcium. We don't know yet. We're going to have to determine that. And all the lead should be gone because we added an excess of the sodium bromide. But remember, we added an excess of the sodium bromide. So what other ions would be in our supernatant, in the liquid? Bromide and sodium. Okay, so those, I'll put maybe calcium in brackets. So we definitely have nitrate, we have bromide, we have sodium, and maybe we've got some calcium. We don't know yet. Okay. The other option, and of course, is to filter it. And if we have in here our lead bromide, we pour it through the filter paper, and the solid ends up here. That's our solid. It's no longer called the pellet, it is called the residue. Okay, it's called the residue. And in this case, that is the lead bromide. Down at the bottom, we have the water, the filtrate, and it contains what ions in this particular case? Na+, Br-, NO3-, and maybe calcium. We don't know yet. So now what we need to do is we need to repeat those original steps to figure out if we have calcium. Where would we go to look to see what we should add next? We will go to our table. So everybody go to your table and find something that will precipitate the calcium. Is sulfate a candidate? Yes, because if we put it with calcium, it will form a precipitate. Yes? Is sulfide a candidate? No, because if we put calcium with it, it is soluble. How about hydroxide? Yes, because calcium would be down in the all others. And how about phosphate, carbonate, or sulfite? Yes, because it's not an alkali, calcium would fall down there. So we could use any of sulfide, hydroxide, phosphate, carbonate, and sulfate. I didn't go with the chloride because it's pretty obvious it's not, okay? So we'll go back here. So we could have SO4 2 minus, OH minus, PO4 3 minus, CO3 2 minus, or SO3 2 minus. Do you have a preference? Which one would you like? Pick one. Yes? OH? Great. All right, so we're going to pick OH minus. So we will now do what with that OH? Find a partner. Who is the partner? Cation. And anytime you need a cation, who is the most obvious choice? Sodium. So what we're going to do then is we are going to add of NaOH. An excess, yes. After we've added an excess of NaOH, what would we write? We would write a statement, and that statement says if a precipitate forms, Ca2 plus is present. If no precipitate forms, no Ca2 plus present. Now, if it asks you to determine which ions are present and separate them all, at that point you would want to do another centrifuge and decant so you could get the solid. But if it just says identify the ions, you can just stop right there. Does that make sense? Okay. So if it asks you to identify and separate, then you would do another centrifuge and decant. Okay. If asked to identify and separate, do another centrifuge and decant. Is good? Okay. So this just walks through what we already did, so I'm not going to go through it. Blah, blah, blah. Since there are no other cations possible, you can just finish here. Yeah. Now we're going to try one where we're determining if we have PO4 or SO4. So last one we were trying to separate cations. This time we're trying to look at anions. Okay, so let's find something. Everybody go find something that will precipitate either phosphate or sulfate, but not both. Yes. Okay, so if we choose calcium, that will precipitate sulfate. What will it do with lead? Where is calcium? Or sorry, what will, not lead. I'm thinking PB. What will calcium do with phosphate? It will also precipitate it, yes? So let's start by listing things that it cannot be. So it cannot be any of those because all of those are down here, yeah? So not silver, calcium, barium, strontium, or lead, because those would precipitate both. Are there any other ions that we could, any other cations that we could eliminate? Yeah, the alkali. Alkali ions won't precipitate the sulfate or the phosphate. And also, well, they're not a good choice anyway, the H and the NH4, because they are acids, but we don't want those because they will not precipitate either. Yes? Okay, so let's go back here. So not, also not alkali ions, NH4 plus or H plus, because they would not precipitate either. Either ion. So who could we choose? Aluminum. Or zinc. Or everyone grab a periodic table and tell me one. Palladium. Yes. Okay. Or anything else. I mean, you could have magnesium. You could have, I don't know, gold, et cetera, et cetera, et cetera. There's like everything except for those ones. Would we like to pick one? Which one would you like? Sorry? Which one? Candium. Scandium. Okay, scandium. Sure. Sc3 plus. All right. So let's choose now an unreactive anion to pair up with the scandium. So who would make a good unreactive ion to partner with the scandium? You guys know unreactive anion? You should. Go look at your table. Find an anion that will not precipitate with anything. Nitrate. Thank you. Didn't you guys know that? Yeah. Okay. Good. I was kind of shocked. Okay. Best choice of an unreactive anion is always nitrate. So we are going to add how much? An excess of who? Scandium. nitrate to the solution. If a precipitate forms, who was present? Now I have to go back and look and say, what were we looking at? We were looking at phosphate or sulfate. And if we added scandium, which is down here, that would precipitate with the phosphate, okay? If a precipitate forms, phosphate was present. If no precipitate forms, no phosphate was present. What do you need to do next? We need to centrifuge and decant. So step number 5, centrifuge and decant, or filter. I always liked centrifuge and decant, and I don't know why. Usually I'm all about writing the shorter option, but I like centrifuge and decant. I think it's because in a real practical situation, you would probably want to centrifuge and decant, because filtering, it takes forever, and a lot of the liquid gets stuck in the filter paper and just evaporates, and so some of the other ions are like stuck in there. So you'd have to have a fairly large volume to do filtration. All right, and now I would like you guys to try and figure out what your next step is. So I would probably say to the remaining solution, what are we going to do? Yes, we're going to add a substance that will precipitate the SO4 2-. So who could we choose? Let's go look. Who could we choose? Calcium or silver or strontium, barium, lead? Yes? Okay, excellent. So do I just do it like this? Add barium? No. What am I missing? An excess. And do I just put barium? No? What am I missing? I need his partner. Who's his partner? Nitrate, barium nitrate. And then after that, our statement. If a PPT forms, SO4 2- was present. If no PPT forms, SO4 2- was not present. And again, if there was another ion, or if it asked you to separate them, you would do another centrifuge and decant. If it just is like identify whether they are there or not, you could stop here. All right. I'm not going to assign this for you. I just wanted to draw your attention to, you know what? I can do that when I assign it, and that's not going to happen till next day, and we've got 1 minute left. What's your homework? Study for your test. Everyone got the new review? Okay, so you have 2 reviews. Excellent. Did everybody get a candy? Okay. Yeah. I don't know. I have to go before my next class starts, so I'm going to go beat the after. Oh, you made me now.
Yo. This is on the sensitivity. Okay.
Oh my god, you are cooking with that costume. Yeah. I'm a tax collector. Oh, that is Oh, hey, you're cooking though, that's so cute. Are you which is I don't think I would do.
It looks like
It's like oh, I'm telling everyone.
You overpaid. You overpaid.
I don't have any more.
You can ask her.
There's Vivian, bro. Yeah, like,
You're going to be getting that with you.
okay. Okay.
Oh, stop. I miss
We need that money. Our government has no funding, so we're like. Okay.
Probably do. Yes.
Hey, why is
What do you have?
Oh, that's a very good question. I would think
That's
hang on a second. Stop recording.
What are you?
No.
Murder